So on the first one, we're going to look at this 8 to the second power, and then when we raise it to the 1/3 power. This is just a power of a power, and our shortcut means that we can multiply our exponents. So we're going to have 8 to the 2/3 power. Now, when you go to like match everything, it might not always match up. In other words, sometimes you have to actually like multiply this out. So if we want to take the cube root of 8, like the cube root of 8 is just 2. So another way for me to write the cube root of 8 is just as 2, and then I need to then go back and square it. So my final answer will be 4, and that's going to match with letter H. All right. Number 2 gives us the exact same properties of our product of powers. We have 5 to the 3/4 and 5 to the 1/2. This means because we have like bases, we can add our exponents, and that's going to give us 3/4 plus 1/2. At this point, we need to get our common denominators. So I need something that equals 1/2, but has a denominator of 4. So if I multiply this fraction by 2 times, 2 times 2 is 4, and 1 times 2 is 2. 2 over 4 is still 1/2. It's the same thing. I just need this common denominator. So 3 plus 2 is 5, and 4 stays the same. So that's my exponent. My base is still going to be 5. All right, so this is 5 to the 5/4 power, and that's letter E. Right. On number 3, that's a totally different type of problem because you have 2 different bases. You've got 64 and 125. The only thing that they have in common is that they're being raised to the 1/3 power. So what you can do is split your numerator and denominator. Yeah, and this strategy will let you take the cube root of 64 and the cube root of 125. Now that's going to put you square out at dot, 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 and dot, dot, dot. Right, so we know that 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So because I'm looking for that cube root, I need 3 of the same factor to match to be able to simplify. And I've got it here with my 4. So this whole numerator is going to simplify to 4, and this whole denominator will simplify to 5. So you could list your final answer as 4 divided by 5. All right, 4 divided by 5 is W. Cool. Number 4 is giving you 2 to the 4th times 6 to the 4th, and then we're going to raise it to the negative 1/4. I do not have like bases, so I can't do anything with that. But what I can do is take this and multiply my exponents. So I could have 2 to the 4 times negative 1/4 times 6 to the 4 times negative 1/4. And now from here, we can go ahead and just simplify our exponents. So yeah, again, from here, we're going to multiply 4 over 1 times negative 1/4 equals negative 1. So this is actually 2 to the negative 1 power times 6 to the negative 1 power. My exponents are negative, and to make to simplify this, I have to have positive exponents. So I'm going to push my numerator 2 down to my denominator 2, and it's going to change from negative to positive exponent. And I can also do the same on the other one. It's going to change from negative exponent to positive exponent. And now I can just multiply my fraction. Very good, because it just goes straight across. 1 times 1 is 1. 2 times 6 is 12. And that means that this is option A. Okay. Let's go on. Number 5 asks you for 3 to the 2/3 power times 5 to the 1/4 power, and then you're going to raise it to 6. Alright, so we're going to take our 2 different powers and our 2 different bases, and we've got a 6 here. So this is like me writing this grouping 6 times. And because it's all multiplication, I'm going to add up my like base exponents. So if I have 2/3 plus 2/3 plus 2/3 plus 2, I'm going to do it like 6 times. And a faster way to do it is just to say 6 times 2/3. And then 6 times 1/4. So that's what I'm going to do just to kind of shortcut this. I'm going to have 3 to the 2/3 times 6 times 5 to the 1/4 times 6. All right. 6 times 2 is 12. And 12 divided by 3 is 4. Yeah, so this is 3 to the 4th power, which equals 81. So we've got 81 on this side. And then over here, I have 6 on the top and 4 on the bottom. And that fraction is just 3 over 2. So this is 5 raised to the 3 over 2 power. Like that. When we go to our answer choices, 5 to the 3 over 2 power times 81 is S. And this is the most simplified that we're going to take it. Another way to write this would be 81 times the square root of 5. That's the square root right there. Raised to the 3rd power. And that's this exponent right here. Totally another way to write it, and it's totally fine. And we know this square root has had an index of 2, and that's your denominator right here. All right, number 6 goes more into this in a little bit of detail, where we have a fractional exponent, and we can change it into a square root if we want to. So on number 6, you're going to have 4 divided by 4 to the 1/2. You can use either powers that you want to do. If you want to say this is 4 to the 1 minus 1/2, which means this is 4 to the 1/2 as your final answer, that's totally fine. The other way to do this is say that this is 4 and this is the square root of 4, right? Because it's 4 to the 1/2. So 4 divided by the square root of 4 is just 4 divided by the square root of 2 times 2. Because I have a match here, that means that this factor is just 2, and 4 divided by 2 is 2. Again, on this way, if you wanted to do it this way, we know that 4 to the 1/2, another way to write that is the square root of 4, and we just solved that problem down here. The square root of 4 is 2. So both ways, no matter what I do, no matter what power you're going to use, you're going to be able to get to your answer. And 2 matches with letter N. Okay. Number 7 is going to be for the cube root of 27, and then we need to multiply that by the cube root of 729. Okay, altogether, you could just put this underneath 1 cube root altogether and try to factor that. But I like what they did here because they kind of just broke it out easier for me. This is a much easier problem for me to tackle than a very big number. All right, so on this one, the cube root of 27 is just what times what times what is 27. Right, so it's 3 times 3 times 3 is 27. So because I have the 3 factors and an index of 3, that means I can simplify to 3. So this whole side, this whole thing right here, is just 3 times the cube root of 729. So now let's split our 729 to figure out what that could be. We got the cube root of something, something, something equals 729. And we're looking for a number that's going to fit the bill. It could be 1. 1 times 1 times 1 is 1, not 729. It could be 5. 5 times 5 times 5 is 125. That's still no good. Maybe we'll try 9. 9 times 9 is 81. 81 times 9 is 729. I need 3 factors to match to be able to simplify, and I've got them. So this goes away to 9. This whole thing here is just 9. So altogether we have 3 multiplied by 9. And 3 times 9 is 27 as the final answer. When you go to match that, that's letter O. All right, number 8. Ocho is asking for the fourth roots of 32. And then we're going to divide that by the fourth root of 256. All right, we don't have like bases. So it doesn't help me to rewrite this at all. Like if I try to do 32 to the 1/4 over 256 to the 1/4. It doesn't really help me because these bases are different. It would only work for me if this was 32 and this was 32 or something like that, and I could still get to it. I could probably do that here. I just want to do it a different way because it's going to be a little bit faster for me to think about. I'm looking for something, 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 something equals 32 divided by something, 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 something equals 256. So we're looking for our factors here. They're going to multiply for 32. So we know this one down here, definitely. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's not going to work for me. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Is it 4? 4 times 4 is 16. 16 times 4 is 64. So that's too much. We can at least try this one, right? We can say that this one is at least going to be 4 times 4 times 4 times 4. Because 16 times 16 is our 256. So we know for a fact that our denominator can just simplify to 4. But our numerator is still going to be the fourth roots of 32. So we still got to work on that one. So I think if we do 2 times 4 is 8. 8 times 2 is 16. And 16 times 2 is 32. That'll work for us. And then what can 4 split into? Right? Another 2 and 2. So 4 times 2 times 2 times 2 times 2. Again, this is all underneath the fourth root. And so I need 4 of these to match. 1, 2, 3, 4 of them will match here. So that means 2 goes on the top. And then I have this extra fourth root of 2. I have an extra fourth root of 2. Good. So let's do that, and that's going to give me the fourth root of 2 over 2. Alright, so number 9 says the cube root of 24 multiplied by the cube root of 12 when we divide it by the cube root of 2. So what we learned last time was to put everything together first and then work on our exponent rules. So we're going to take that lesson to heart and do that now. We're going to say that this is the cube root of 24 times 12 divided by the cube root of 2. Now from here, I want to break 24 and 12 down further. I want literally, like, they need to be like 2s and 3s and 1s and all that good stuff. We need to break them all the way down. So, because I need all my spare parts. So 12 will factor for me into 2 and 6. And 6 turns into 2 and 3. So this is what I'm going to use to represent 12. And now let's do 24. 24 is 2 times 12. So I'm going to do 2 times, and then here's my 12. 2 times 2 times 3. All of this gets divided by the cube roots of 2. Alrighty. I need 3 factors to match up to get out of here. So I've got 1, 2, 3. That 2 can leave. I've got 1, 2 3s left, and 2 2s left. I'm going to take one of my 2's, and because it's the cube root of 2, and I'm dividing by the cube root of 2, this is the same thing, numerator and denominator, which will go away for me to 1. Because it's the same thing, it's the cube root of 2 divided by the cube root of 2, which is 1. And then that means all I have left is 3 times 2, which is 6. 6 times 3 is 18. So this is the cube root of 18. I have a 2 on the outside, and I don't have any denominator left because I made it equal 1. So 2 cube roots of 18 is going to match with letter S. Number 10 gives you a fraction again. And we're going to do numerator first and then denominator, just like we did this time. It's 25 to the 1/6 power times 25 to the 1/3 power divided by 5 to the 6/5 power. Okay. So if I have like bases, they let me add my exponents. And the first thing I need to do is add up my 1/6 and my 1/3. I do not have a common denominator, so that's going to have to happen here. I can multiply this one by 2/2, which is fancy 1, because 2 times 3 is 6, and 2 times 1 is 2. I can check 2 divided by 6 is still 1 divided by 3, so it's the same thing. Now I can go ahead and add 1 plus 2 is 3, and my denominator stays the same. 3/6 happens to equal 2. So that's my exponent, and remember my base was 25, and that's my numerator, 25 to the exponent of 2, 25 second power. On the bottom, I've got 5 to the 6/5 still. Now would be an excellent time to get like bases, because I want to subtract these two exponents. So what I'm going to do is I'm going to write 25 as 5 squared, and then I'm going to continue on with my problem. Now I can use power over power to combine these two into 5 to the 4th power. Now it's time for me to subtract my exponents. I need to subtract 4 minus 6/5. So we're going to have equals 5, 4 minus 6/5. I'm going to just look at this exponent first. So when we multiply 1/2 times 2, we get 1. This is 5 to the 1st power. 5 to the 1st power on the top. On the bottom, remember we still have 5/6 to the 5th. So 5 to the 1st power divided by 5 to the 6/5 power. All right, we can subtract our exponents. This is going to be 5 to the 1 minus 6/5 power, which is going to be 5 to the 5/5 minus 6/5 is negative 1/5. So 5 minus 6 is negative 1, and I'm going to keep my common denominator here like that. So I have 5 raised to the negative 1/5 power. This isn't quite simplified yet because I can't use negative exponents. To make this exponent positive, I'd have to push it, the whole thing, into the denominator. So I'm going to put it in the denominator. Now when I do that, the whole purpose for me doing that is to change the sign of the exponent so that it will be simplified. So negative 1/5 becomes positive 1/5, and this is going to be option O, letter O. All right, number 11 is going to show up on the quiz. And we didn't specifically go through it in class, so I definitely want to address it now. Number 11 says 4 divided by 8 minus the square root of 3. And remember that we cannot have square roots in the denominator ever as like a simplified answer. So we're going to have to multiply this by what's called the conjugate. The conjugate is the exact same factor that you see here, just the opposite sign. So instead of 8 minus the square root of 3, you'll be multiplying by 8 plus the square root of 3, like that. And this is totally okay for me to do because this is one thing divided by itself, which is just fancy 1. It's the same thing as 1. All right, so let's take a look at our denominator first. We're going to need to multiply these two factors together, these two binomials. We'll go into our array, and we're going to have 8 minus the square root of 3 and 8 plus the square root of 3. This is going to give me 64 minus 8 square roots of 3 plus 8 square roots of 3 minus 3. I've got minus 8 square roots of 3 and plus 8 square roots of 3, so those go away. Again, we're working on my denominator, so you want to keep that in your head when you simplify. What is 64 minus 3? That goes to 61. So my denominator is now 61, and that's how you get rid of this square root. Okay? So now we need to do the numerator, and it's just going to be simple distribution here. So my numerator is still going to be 4 times 8 is 32. And 4 times the square root of 3 is 4 square roots of 3. When I look at my options, 32 plus 4 square roots of 3 divided by 61 is B. A little bit. Number 12 is going to say 10 fourth roots of 5 minus 3 fourth roots of 5. So this problem is just saying you have 10 of something, and you want to subtract 3 of something. So 10 of something minus 3 of something is 7 of that something. And that's all you would need to write out, is to combine these together. 10 minus 3 is 7, and you're going to have the same family back here. These are like radicals. 7, and then the fourth root of 5 is letter R. (13) is thankfully going to be virtually the same kind of thing. You've got 12, and you're going to multiply it by 4 to the 3/4 power. So we're talking about 12 of something, and we need to add it to 5 when we go 4 to the 3/4 power. So this is 12 of something, and we're going to add 5 of something. Another way to maybe think about this that may be familiar to you is like 12x plus 5x is going to give us 13x. And here, the same logic is going to apply. We should be able to say 12 and 5, and we get 17 times 4 to the 3/4 power. And for that one, you're going to be looking at I. Yeah, 12 plus 5 is 17, not 13. And so that's how your final answer will be written. Number 14 is the 5th root of 3 to the 5th power. This is a really interesting problem because you could spend the entire time here like trying to expand this out, right? Or trying to break it down. Or we could say, hey, we're in Algebra 2 and we need to stop maybe using this radical so much and start using our fractional exponent like we're supposed to. Because I think if you do that, you're going to see the answer very clearly. You see that you've got 3 to the 5th, and that stays as is. And now we need to raise it to the 1/5 power. So what you're about to do is multiply 5 times 1/5, which is just 1. So this whole thing will simplify down for you to 3 to the 1st power, which is just 3. And that's answer option G. We've only got 2 more to do, and they're pretty straightforward. So we've got little guy here, 15, says 3 to the 2/5 power, raise it to the 1/2 power. Again, just power over power lets you multiply your exponents so that you're going to come out with 2/5 times 1/2, which is 2/10, which another way to write that is 1/5. So 3 to the 1/5 is going to match up with letter H. The very last one that we're going to do together is number 16. We have -3 of these 2 to the 1/5 powers. And then we've also got negative 2 of these 2 to the 1/5 powers. When taken together, this is literally like negative 3 of something and negative 2 of something. So altogether, you'd have negative 5 of that something. So this is going to be negative 5 times 2 to the 1/5 power. And you're going to see that in letter T.